The seventh principle of the green chemistry is using renewable feedstocks. The concept of making all our future fuels, chemicals, and materials from feedstocks that never deplete is a challenge because mankind currently removes fossil fuels, coal, oil, and natural gas from the ground until they're exhausted. They're being rapidly depleted with the rise of global populations and the expanding use of energy throughout the world. But over the past 10 years, significant advances have been made in the development of fuels, chemicals, and materials from renewable feedstocks. A feedstock is defined as any renewable or biological material that can be used directly as a fuel or converted to another form of fuel or energy product. We also call it biomass. Currently, we manage to create biodiesel from plant oils and algae, bioethanol and butanol from sugars and lignocellulose, plastics, foams, and thermosets from lignin and plant oils, and even electronic materials from chicken feathers.
A good renewable resource example that is starting to spread is coppicing of timber. It consists in cutting trees very low to allow them to grow again faster than before and to last longer. A properly managed woodland can supply infinite timber resources. Another good example of renewable feedstocks is the use of polyfarming. It's the fact of using a land for different purposes. In China and Japan around the early 20th century, farmers would use the rice paddies, which were flooded part of the year, to grow fish. The fish would be used as food and they would clean up the paddies and create fertilizer. So most renewable feedstocks require a cycle system, which has little or no chemical or artificial inputs. They grow themselves, replace themselves, and require minimal human care.
The eighth principle of the green chemistry is to reduce derivatives. Derivatives are used as temporary intermediate molecules between the start and end products. Such multi-stage processes require the input of more resources and chemical reagents. Therefore, the minimization of such steps is desirable because most of the time derivatives are used to shape the molecules into what we want them to look like. The principle aims to simplify that process and to look at natural systems in order to design products in a simplified manner.
One of the best ways of doing this is to use enzymes. Enzymes are so specific that they can often react with one side of the molecule only and leave the rest of the molecule alone, and hence the protecting groups are often not required. Therefore, the wastes are reduced.